Everyone, now in previous lecture we have understand about the theory of coplanar concurrent forces. So let's revise all that things first. What is coplanar concurrent forces? When the acting forces line of action lies in a same plane and meeting at a point to each other, said to be coplanar concurrent forces. In that case, first we have understand about what is force. Means an agent which produces or tends to produce, destroys or tends to destroy motion of the body is called force. That we have understand. Characteristic of forces in that magnitude, direction, nature, point of application, that also we have understand. Type of forces, which type of forces is surrounding us, that we have discussed. What is mass and weight, that we have discussed. System of forces, this is most important. Coplanar forces, concurrent forces, collinear forces, coplanar concurrent forces, coplanar non-concurrent forces, non-coplanar concurrent forces, non-coplanar non-concurrent forces. Then like parallel forces, unlike parallel forces. After that, spatial forces means those forces who acting in a space, that is spatial forces. In that, spatial concurrent forces, spatial non-concurrent like parallel, and spatial non-concurrent unlike parallel forces. These force systems are frequently used in our calculation of building design. So it is most important for us. After that, principles of physical independence, then superposition of forces, then transmissibility of forces, that we have understand in previous lectures. The most important thing, that is resultant force. So what is resultant force? Whenever a number of forces are acting on a body, then body is going to move in a single direction. So that direction and the magnitude at that directional force, that is called resultant force. And this is most important thing for us. Why? Because whenever a whole forces of the building is acting on a footing, that you know what is footing. So we can design that foundation and stabilize the building. What is the basic need of finding out this resultant force? Because whenever a number of forces are acting on a body, then body is going to move in some direction. So we can consider opposite force of that resultant force, so we can balance the whole system and hold the body. Now composition of forces, this is most important. Which are the method used for the finding out the resultant forces? So in that case, there are two methods, first analytical and second one is graphical. In analytical method, there are three methods. First one is parallelogram law of forces, resolution of forces, and triangle law of forces. And in graphical, there is polygon law of forces and triangle law of forces. So for the finding out the resultant, first we have to finding out the equations which is based on the analytical method. So what is parallelogram law of forces? That also we have studied in previous lecture. So in parallelogram we can derive two equation, that is r is equal to under root of p square plus q square plus 2pq cos theta, and the second one is tan alpha, that is direction of our resultant force, that is tan alpha is equal to q sin theta upon p plus q cos theta. So these two equation is most important for us because it is analytical method, and in analytical method we can finding out the resultant force and that direction with the help of these two equations. Now triangle law of forces, this is also one analytical method, and in that case we have again two equation for that resultant and direction of that resultant, and the equations are r is equal to under root of p square plus q square minus 2 pq cos beta, and the direction of that resultant force, that is alpha is equal to sine inverse in the bracket q upon r sine beta. So these two methods is used as an analytical method, and third method, that is resolution of forces. So what do we mean by resolution? That also we have discussed in previous lecture, but still today we are going to continue this method, so we are going to repeat that things. Resolve, that means the effect of the force in particular direction that is known by us, means the resolution of force is basically two type of resolution. First one is orthogonal and the second one is non-orthogonal. What do you mean by orthogonal? Means forces are resolved exactly 90° with each other. So basically you know which are the main direction. There are two direction. Here we are understand the chapter that is coplanar, means the forces are acting in a single plane, and in a single plane there are two direction x and y. So we know the main direction, that is x and y direction. So the force is moving in any direction, but we are taking consideration of, means the effect of that force on x and y axis, that is called orthogonal resolution. So how it works? And second one is non-orthogonal components, means forces are resolved in two directions, but they are not exactly 90°. It can be less than 90° or else it can be greater than 90°. So here we are going to understand about first orthogonal component. So this is our first force P, which is in a first quadrant, and the resolution of this P force on x axis as well as on y axis. So as per the triangle theory, that is right angle triangle method, Pythagoras, the P force is going to move on x axis, then it is P cos theta, and on y axis it is P sin theta. That you have understand previously in 11th 12th, or else for the D2D student that understand by you in applied mechanics subject. Again this is in a fourth quadrant, so it is second quadrant, it is P cos theta on x axis and P sin theta on y axis. Here theta is towards the x axis, so whenever our force is moved towards the given angle, it is cos, and opposite to that angle, that is sine. So here whenever the forces are resolved orthogonally, it is always in the form of cos and in the form of sine. Now non-orthogonal component, it must be calculated with the help of triangle law of forces as well as parallelogram law of forces. So and we have equation for that. Now, why we are considering this thing? Because whenever number of forces are acting on a body, then the resultant is single. For that, we have to first component of that all forces, and after that we can finding out the resultant force. So, resolution of forces more than two forces and what it can and how it is calculated. For that, first we have to take components of all the forces on the x-axis as well as on y-axis. Whenever the all forces along x-axis, then summation of that is sigma h, and whenever they all component about y-axis, then it is sigma v. So, sigma h is equal to algebraic sum of all the horizontal forces, that is converted from the given force, and sigma v again it is algebraic sum of all the vertical forces. Now, the resultant force from that two force is under root of sigma h square plus sigma v square, and direction of that force is equal to tan theta is equal to in the bracket in the mode sigma v upon sigma h. Now, from this we can calculate all the horizontal forces and finding out the resultant as well as its direction. So, whenever number of forces are acting on a body, then we can calculate the resultant force with the help of sigma h and sigma v, and for that we have to take components of this force on the x as well as on y axis. The most important thing, that is free body diagram. Now, what is free body diagram and why we are considering that free body diagram? So, we know each and every things that surrounding us which is resting and stable on that position with the help of some support. Suppose I am talking about the fan. Fan is hanging on a ceiling with the help of hook, but that fan is in stable position because ceiling is going to give reaction. Suppose we are standing on some bench, sitting on bench, then we are sitting on that bench, but still we are in a stable position because a bench is going to give reacting force. So, if any body which is in a rest position and that rest position with the help of some support, here we are going to finding out that reaction of support with the help of LAMI'S theorem. Suppose this is a sphere and this sphere is hanging through a string and that string is connected with the vertical wall. Now, the thing is that this sphere can't falling down because whenever it going to falling down, a string is going to react, as well as it can't be moving leftward because a wall is there, it is also going to give reaction. So, in free body diagram, what we are going to do? We are just removing all the support and make the body free from the support, and instead of that support we are considering reaction of that support and finding out that reactions. Like this, support this wall is going to give reaction towards the right and it is somewhere over here. A string is pulling upward, so the tensile force is generated by that string, it is upward, and the weight of that sphere is going to downward. Now here we have weight of this sphere, but two unknown reactions are there, and that two reactions must be finding out by us with the help of LAMI'S theorem. Whenever any body that can be in rest position, it must be with the help of some support, and we are going to finding out that reaction of support. That's our duty. So what is LAMI'S theorem? This is most important thing. LAMI'S theorem is totally depending on the sign rule, and that you have understand in a previous 11th-12th science. What it? This is our P force, this is Q force, and this is R. The angle between that P and Q is gamma, P and R is beta, and Q and R is alpha. What exactly going to do with the help of sine rule? P upon sine alpha, that is exactly opposite to that P, is equal to Q upon sine beta. Beta is also exact opposite to Q, and the gamma, that is also opposite to R. So the equation which is formed from the sine rule, that is P upon sine alpha is equal to Q upon sine beta is equal to R upon sine gamma. Now consider that the forces P, Q and R acting at a point O, let opposite angle to three forces, that is alpha, beta and gamma. Now we can draw the line from OA equal to force P. This is our force P and this is OA line. OB, that is over here, some scale. Now complete the parallelogram. This is parallelogram which is formed by that. Now here that is 180 minus beta, this is 180 minus alpha, this is again 180 minus alpha. Now this is 180 minus beta. So we can calculate these angles from the our rule of triangle. Now OA upon sine ACO, this is ACO, CA upon sine COA and OC upon sine OAC. Now we have the angles 180 minus alpha, 180 minus beta and all that. So now whenever we are going to put this angle somewhere over here, then we can calculate the equation and derive that equation. P upon sine alpha is equal to Q upon sine beta is equal to R upon sine gamma. So this LAMI'S theorem is most important for the finding out the unknown reaction for the free body diagram. Clear everybody? Okay. Now the next thing, that is type of equilibrium. Here there are three type of equilibrium. First one is static equilibrium. A body is said to be in a stable equilibrium if it is returned back to the original position after it is slightly displaced from the position of rest. This is static equilibrium. Unstable equilibrium, a body is said to be unstable equilibrium if it does not return back to its original position after slightly displaced from the position. And natural equilibrium, a body is said to be a natural equilibrium is occupied a new position after slight displace like this. So, this is our curvature, and a body is slightly moved, then it will be stable afterwards and come back to its original position. But it is something like this curve, then it will be moved away from there, and this is a natural equilibrium. In that case, it will be take new position after displacement. Clear? So, this is our equilibrium. Now, the theory portion is completely over here, and from next lecture we are going to understand how to calculate the resultant force and its direction with the help of our first analytical method, and that is parallelogram law of forces. So, for that you have to take with a calculator, and you can calculate that resultant force and its direction with the help of parallelogram. Clear everybody? Thank you. Thank you so much.